Okay, so yesterday we talked about finding limits graphically and with a table. Now we're going to do it algebraically, and we started doing this yesterday. Finding the limit as x approaches 4 of x squared plus 2. What did we talk about yesterday? If I wanted to find that limit, what could I do? I'm going to take 4, and I'm going to do direct substitution. I'm going to plug it in. And so to find this limit would be the same thing as finding 4 squared plus 2. So my limit is going to be 18. You could graph that. You could use a table, but all of them are going to get you the same answer. The answer is 18. The first choice you always want to do is direct substitution. It's the easiest form of doing this. Take the number, you plug it in. Try that with letter B and C. Direct substitution. Don't overthink it. Plug it in, see what you get. Show me with your fingers what'd you get for B. What'd you get for B? Show me, please. 6. You take -3, you plug it in. -3 plus 1. That's -3 times -2. That's 6. Done. That's my limit as x approaches -3. Letter C. Show me with your fingers what'd you get for C. 3. Plug it in. It's 2 squared plus 4 plus 4. That gets you 12 on top. On bottom, it's 2 plus 2. That gets you 4. 12 divided by 4. That's 3. Boom. Done with that one. Direct substitution. It's a really easy way to solve limits. Let's look at letter D. Do direct substitution. Plug in 1. 1 minus 1 over 1 squared minus 1. You get 0 over 0. What does that mean? Is that 0 or is that undefined? It is neither. 0 over 0 is not undefined. It is not 0. That is indeterminate form. You don't ever have to write this out. Oh, gosh. That's a lot of writing. Indeterminate form. Okay? Indeterminate form means I don't know what's happening. All right? There is a mystery afoot, and we need to solve that mystery. Why are we getting 0 over 0 for this problem? Because there's a hole. We did this back in November when we graphed polynomials, and we got holes. And if you remember, once we found a hole, we wanted to get rid of the hole. Anybody remember how we got rid of a hole in a polynomial? We crossed them off. We factored them, and we canceled them out. So that's what we're doing. If, when you get 0 over 0, one way of getting rid of 0 over 0 is factoring, canceling, and plugging back in. Can I factor this problem? So let's do it. On top, it's x minus 1. On bottom, what am I going to factor x squared minus 1 into? X plus 1, x minus 1. We factored. Now we're going to cancel. We're going to cross out the hole. All right, we said there was a hole. There is one. It's at 1. We factored. We canceled. And we plugged back in. What is my answer going to be here? Don't say 2. That's everyone's favorite answer here. The answer is not 2. What is the answer going to be? 1/2. Because that 2, when I take that 1 and I plug it back in, it's on bottom. Don't let it magically come to the top all of a sudden. The answer is 1/2. Make sense on how we did that one? Factor, cancel, plug back in. Try E and F doing the same thing. We plugged in. We got 0 over 0. So we looked at it. We're like, oh, we can factor it. We factored. We canceled. We plugged back in. Looking at letter E. Garrett, what'd you do first on letter E? No, don't do that yet. What did you do first? He plugged in first. The first thing he always does is make sure that it gets him 0 over 0. Because if it didn't, that'd be bad. He's going to plug in 4. And when you plugged in 4, what did you get? 0 over 0. So because he got 0 over 0, he then realized that he could factor, he could cancel, and he could plug back in. But he did that first. He's got to make sure it's 0 over 0. Once we got 0 over 0, we're going to factor this thing. And so, Alyssa, what did you factor the top into?
X plus 5, x minus 4.
Yep. So we factored. And then, Amanda, what are we going to do after we factor that thing? We're going to cancel out, and we better have something that cancels. There's a reason why we got 0 over 0, because there was a hole. And then, Aisha, what are you going to do from there? Plug in 4, and so what do we get for our final answer? It's 9. The 9 is on the top. It's in our numerator. My answer is 9. Everybody good with that one? Letter F. Show me with your fingers. What'd you get? Yeah, it's D and E. It's undefined here. We're going to start off. You shouldn't just try to factor it. Okay, we're going to plug in 2 cubed minus 1 over 2 minus 2. That is 8 minus 1 over 0. It's 7 over 0. 0's on bottom. Is that 0 or is that undefined? That's undefined, and so my answer is D and E. 0 on top, 0 over 7, the answer is 0. But in this case, it's D and E. Make sure you don't mix those two up. Questions with those? Those types of problems are the basic limit problems we're going to do for this chapter. Every once in a while, they throw in this guy down here on example 3, and they're just doing it because they're mean. All right? Look at example 3. What are you going to start off by doing on example 3? Plug it in. Plug in 0. See what you get. I plug in 0 and I get 0 over 0. I get 1/3 minus 1/3 on top, and I get a 0 on the bottom. So it is 0 over 0. And so, darn, it's indeterminate form. So normally we would factor, we would cancel, we would plug back in. Can you factor this guy? There's not any factoring going on. There's no polynomials. And so the other instead of factoring, canceling, plug it in, we're going to simplify, cancel, and then plug back in. Simplifying here is not your favorite thing in the world. We're going to do some good algebra skills, but that's what this question is. It is an algebra question more than a calculus question. All right. So what we need to do is we need to take this complex fraction and make it into a single fraction. So no more subtracting on top, no fractions over fractions. We got to do some skills to get us to that point. Annoying, but you can do it. Thoughts on what we could do? Good. I'm glad a lot of ideas are happening here. I'll give you a couple suggestions. Okay? I don't care how you approach it. On top, you could rewrite that as a common fraction. How are you going to subtract two fractions? Common denominator. You could get common denominators on top, combine them, and work from there. I'm going to do it a different way, but it's the same concept. It doesn't matter which way you do it first. I don't like a fraction over a fraction, so I'm going to get rid of that other fraction here pretty quickly. If it's divided by x, it's the same thing as taking that top fraction, 1 over 3 plus x minus 1/3. And if it's divided by x, it's like multiplying both of those fractions by 1 over x. That's the same thing, just written in a different way. Dividing by a fraction multiplied by the reciprocal, it's the same thing. Okay, I multiplied both parts by that. So I'm going to multiply that out. So this is 1 over 3x plus x squared minus 1 over 3x. So we got rid of that other fraction. Now we just have one fraction. That's better than what we started with. We don't have crazy double fractions anymore. What happens if I plug in 0 here? Yeah, we get some undefined stuff that doesn't really work still because we're getting zeros. They cancel each other. It gets weird still. We're not there. We need to keep simplifying. And so what we need to do next is we need to take these two fractions and we need to put them together. In order to add or subtract two fractions, what do I need to do next? Common denominator. So to do that, I'm going to multiply this fraction by 3x on top and bottom. And I'm going to multiply this fraction by 3x plus x squared on top and bottom. Do that. It's going to take some algebra work, but multiply those out and see what you get. Okay, so I just multiplied these together for you. The stuff in yellow, I multiplied top and bottom by 3x. They gave me this in yellow. The stuff in black here, the negative 1 over 3x, I multiplied that by the same thing on top and bottom. That's what gave me the stuff in green over there. I now have common denominators. Now that I have common denominators, I can actually subtract the two things. And so I'm going to rewrite this problem so that both denominators are 9x squared plus 3x cubed. And so I can subtract on top. It's 3x minus that. So if it's minus that, don't forget to distribute that negative sign. So this really becomes plus, that becomes minus, that becomes minus. What's going to happen to my 3x's? And then I get negative x squared left on top. What happens when I plug in 0 now? You still get 0 over 0. It didn't help us at all. But what we did is we now simplified this and we made it one problem. Now that I've simplified it, is there anything else I could do? I can now cancel an x squared because everything in this problem has an x squared in it. And so because every single thing has an x squared, I'm going to take an x squared out. And so when I do that, I get negative 1 over 9 plus 3x. Now I simplified, I canceled. You got to cancel. If you don't cancel, you can't get anything better. Okay, but now that I've canceled, now what happens when I plug it back in? Negative 1/9. If I gave you all of the tools at your disposal, if I said you could use your graphing calculator on this, this is not the most efficient way of doing it. Type it into your calculator, do a table, and you can find the answer really quickly. All right, I'm not giving you that option, and so this is the best way to do it, is by simplifying that thing. Don't be stressed out. If you don't like that problem, I understand why you don't like it. It's not super fun, but you can do it. It's just algebra skills. Questions there? This question is important, so don't get lost on that last one. Piecewise functions are one of our most important things that we do in calculus, especially in the first couple chapters here. We do piecewise all the time. Okay? There's a piecewise function. You don't have to graph this in order to answer these 3 questions, but a graph will help us out. So graph that piecewise function right there on the graph real quick. Here's my graph. I graphed x squared, so I graphed a parabola when x is less than 2. So I graphed it from 2 to the left. Then it says graph 2x minus 1 when x is greater than 2. So I'm starting over here, and I'm doing a slope of, so I'm graphing 2x minus 1. I'm starting down here at negative 1. I'm going up 2 over 1, up 2 over 1. And that's really an open circle because it's not equal to. And then up 2 over 1, up 2 over 1. Do these 2 graphs connect? No, there's just a little gap there in between the 2. All right, we have that picture. We don't necessarily need it, but it's going to help us better understand. Find the limit as x approaches 3. Which one of these 2 equations that they gave us do I care about if I want to find the limit as x approaches 3? 2x minus 1, because 3 is greater than 2. So cool. All we need to do is direct substitution into 2x minus 1. So 2 times 3 minus 1. What's my limit going to be? It's 5. And we could do that by looking at this table, okay, or looking at the graph. If I were on this graph over here and I were to walk on the left and the right-hand side as we approach 3, we would get closer and closer to 5 like we did. Okay, cool. The limit's 5. Question B, find the limit as x approaches 1. Which one of those 2 equations do we want to look at if I want to find the limit as x approaches 1? X squared, because 1 is less than 2. I plug 1 into that thing, my limit is going to be 1. And again, we could walk on this graph, approaching 1 from both sides, and my y value is getting closer and closer to 1. Here's the important one. Find the limit as x approaches 2. Which one of these 2 equations do we care about if we're finding the limit as x approaches 2? The answer is both. The answer is both, because go back, okay? Zach, you were quick to say it. What do we look for when we talk about limits? We have to look at both sides of our graph, and so make sure you're doing that. We got to look at both sides. I don't care that that one's underlined. My last class said, oh, the top equation because it's underlined. I don't care. I don't care what happens at 2. I care what happens as we approach 2 from both sides. And so to find a limit, we really need to look at this limit 2 from the left-hand side, and it needs to be the same as the limit as x approaches 2 on the right-hand side. We need to look at both sides of this problem. And since I have 2 equations, to write it out like this would make sense. Which equation is going to tell me the left-hand side? The top one, the x squared equation. So we're going to plug into that, x squared. And so if I plugged in 2 there, I get 4. What about 2 from the right-hand side? That's plugging into this equation. So into that 2x minus 1 equation. What do I get when I plug into that guy? 3. Is 4 equal to 3? No. So what's true about my limit? It does not exist. And it would make sense looking at this picture. If you walked on this line as we approach 2 from both sides, you're approaching different numbers. Therefore, the limit doesn't exist. Questions on that one? Flip it over. We're going to go through this next one pretty quickly. This is a graph you need to know. We graphed this in our calculator quickly yesterday. If you don't believe me, type in some numbers. Okay, I'm just going to show it on your calculator real quick. This is the absolute value of x minus 3 all over x minus 3. I'm finding the limit as x approaches 3. What happens if you plug in 3 on top and bottom? I get 0 over 0 if I plug in 3, right? Because I get 0 on top, 0 on bottom. That's indeterminate form, okay? There's a hole in my graph. All right, so I can't just do direct substitution. I wish direct substitution would work. There's a hole right here. But what I can do is I could look at the graph and understand the graph. If I plug in a number less than 3, I get a line at -1. Plug in any number less than 3 and see what happens. You're going to get -1 because on top you're taking the absolute value, on bottom you're not. If you plug in a number bigger than 3, you get +1. But there's nothing at 3 because there's a hole. The hole doesn't really matter here. We're just looking at the left side and the right side. Are my numbers approaching the same thing? No. One's approaching 1, one's approaching -1. What's my limit going to be? D and E. Again, just for time's sake, the second one would be the same. What do you think the limit's going to be as x approaches 0? It's D and E. It's D and E. All that changed on this graph was it got multiplied by 2. And so that's what my graph looks like. It's still D and E because there's that weird gap in the middle. That is a graph that has happened pretty much every AP exam the last few years. Make sure you're good at those. Let's look at example 6. These are the tough ones. So if right now you're okay, be okay still. All right, don't let today kind of wear you out. These questions down below have started to creep into the BC exam, and they're not the best. You're not going to be your favorite problem of all time. I apologize that you're not going to love them, but deal with it. Find the limit as h approaches 0 of h of g of x. All right, it is not what you think it is. Here is the key to finding composite problems. Rewriting this guy. Okay? When you see this, this is the same question of h as the limit of x approaches 0 of g of x. Or in other words, the limit part only applies to that first, the inside composite function. We are only doing the limit of g. Once you've done the limit of g, then it's just an h of problem. We're going to figure out what the limit is inside here, and then we're going to find h of that number. So looking at my graph, what is the limit as x approaches 0 of g? It's 0. As I approach from the left and the right-hand side, I'm getting closer and closer to 0. So this guy is 0. And now I'm doing h of 0. So I'm going to my graph, h of 0. Show me with your fingers, what is h of 0 going to get you? H of 0 is 3 because you've got a closed dot right there. The answer is 3. We do the limit of the inside composite function only. Try example B. See what you got there. The key to that one is rewriting it. 3s, let's check it. We're finding f of the limit as x approaches 3 g of x. So we're going to start off with the inside part. We're finding the limit as g approaches 3. As we approach 3, as we go from the left side and the right side, we're getting closer and closer to 2. Then we are finding f of 2. We go to my f graph. We go to the actual dot at 2, and that guy is going to get me 3. Make sense on that one? I'm going to skip C for now. The answer is actually 2. If you went ahead and tried that one, and the key to that is the absolute value, and so you're really only looking for that graph on the right-hand side, which is a little bit strange. I want to get to letter D. So letter D, this is the question that pops up on the AP exam. It popped up a couple years ago, or last year, I think. Limit as x approaches 0 of g of x times the limit as f approaches x plus 2. Let's just look at it together for a second. The limit as g approaches 0. What's that number going to get you? 0. So g of x is 0. And then if you look at the limit as f approaches x plus 2, or in other words, we're going to plug in 0 for x. We're really looking at the limit as x approaches 2. What is the limit as x approaches 2 on the f graph? It's D and E. right? Because I'm approaching down here and up there. The answer to this question is not D&E, though. All right? When you see these types of problems, I'm going to tell you the answer is normally not D&E. They're trying to mess with you a little bit. And so double check yourself. Here is how you have to approach this problem. Okay? Just like the one we did earlier, I want to know the limit as x approaches 0 from the left, and I'm going to compare that to the limit as x approaches 0 from the right. This is a weird thing to look at, all right? You just got to trust me on it a little bit. So let's set this problem up. I want to find the limit as x approaches 0 from the left-hand side of g of x. So if I look at my graph, what is that answer going to be? It's 0 because I'm approaching it from the left-hand side. It's still 0. That didn't change. So this guy is 0 times x plus 2, but I only care about the left-hand side of this graph. What is the limit of f as I approach it from the left-hand side? -1, because I'm over here at 2. It's -1. 0 times -1 is 0. Then we're going to do it from the right-hand side. So I'm looking at the g of x equation, but I'm only looking from the right-hand side. So as I walk this way, I get closer and closer to 0. That didn't change. I am multiplying that by the x plus 2 from the right-hand side. What am I going to get as I approach it from the right-hand side? That is 3. What is 0 times 3? In order for a limit to exist, the left-hand side and the right-hand side need to be equal to each other. Are they equal to each other? It's weird. It doesn't make a ton of sense, but they are equal to each other. Since both sides are equal, the limit to that question is 0. Again, as you look at that, if you get D and E, take a step back and think, would it be different if I only looked at it from the left-hand side and the right-hand side and compared those answers? Try letter E real quick. Think of that approach with your neighbor for a second. I screwed up C. The answer was 3. Let's look the limit as, again, if you just looked at this problem, you would think it's D and E. All right, but it's not here. We're going to look at it a little bit different here. We are approaching this thing from the left-hand side and the right-hand side. If I approach this guy from the left, I'm going 2 from the left of my f of x equation. So 2 from the left, oh cool, that's -1. -1 squared minus 6. -1 minus 1 is -2. -2 squared is 4. Minus 6 is -2. That is what I get here on the left-hand side. I want to see, is that equal to the right-hand side? So we're doing the same thing. Now I'm going 2 from the right. So up here I'm going 2 from the right. I'm getting closer and closer to 3. -1 squared minus 6. 3 minus 1 is 2. 2 squared is 4. Minus 6. Oh, cool. That is also -2. So the limit is -2. Left-hand, right-side approach. If you have a weird graph that's split up and it looks like it's D and E, that's what you want to make sure you do. Questions on something we did today?